I'm a postdoctoral fellow at the HITLab, and I'll be taking part of the evaluation part of the course. So welcome to my first lecture. First of all, my background, I'm originally from Korea, and I've been working at the lab for about 3 years now. So the previous semesters, I think Dr. Andres Dunzer used to teach this topic before, so that's why you see his name beneath there. Some of the slides are from himself, and some of the slides are from Mark, and some of the topics are actually from Stanford B School. Morning. So maybe could start from a brief overview of our lecture. So these are some of the topics we are going to cover during this lecture. So I'll be covering quite a lot of various topics related to evaluating your own research prototypes. But in overall, it will be a mixture of experimental methods that you can use and some of the statistical tools that you can use to analyze your study results and so forth. So first of all, maybe since it's our first lecture for this time, maybe if you can go around and introduce ourselves, and maybe if you could mention briefly about what's your interest in terms of human interface technology, that could be also a good starting point. Maybe we'll start from you, Robin. Yeah. So, do you have any particular interesting topics that?
There's like side projects that like to apply the stuff to
game making. Okay, so yeah, game is definitely one of the topics in HCI, and making it fun is, in certain ways, it involves quite a lot of human-computer interface design. So, and Marie?
Yeah, my own company, it's 360. Produce which website tools I'm interested in coming years to introduce those to 3D modeling. Virtual 3D modeling.
So virtual tools and 360 photos, virtual modeling 3D.
So you can throw and open a virtual tool with them.
Oh.
I know there's a lot of commercial interest out there for that.
Yeah, great. So it's for that. And
I'm a graduate from HITLab NZ. I'm interested about probably looking into the gamification of healthcare systems or global systems where you can make it easier for people that don't have a programming and modeling skills to create their own virtual ones.
So it's gamification of authoring environments. And
I'm currently a developer in one of the software companies here. My interest is in interaction design, especially for wearable technologies like Mayo, Google Glass.
Google Glass, mostly wearable technologies you're interested in. Oh, so thanks for introducing yourselves. And so during my lectures mostly will be on Tuesdays from 10. I'll be covering some topics. Today I'll cover briefly an overview about HCI research itself, what kind of things you might expect in the end of your whole master course, throughout your master course, what you'll be doing and what you'll be looking at, and probably that will give you a little bit of overview or a guideline that what you'll have to produce in the end as a thesis, let's say. And especially my session of lecture will be focusing on evaluation of your own human-computer interface or a prototype system that you'll be developing throughout your projects. And the evaluation itself could be include quite a variety of topics, but mostly I'll be covering various overview of various way to evaluate your prototypes and your designed interface, and especially focus on how to design user experiments and how to do them, some technical tools and methods that you can use while you do your user studies, and also a little bit of statistical tools that you can use to analyze the results afterwards. So those are the topics we'll be covering. So for today, I'll be roughly going through introduction to HCI research and the evaluation part. What does it take in terms of the HCI research? So these are some of the books that I will be basing my lectures on. So the one on the left side is called Research Methods in Human-Computer Interaction, and this will be the main book that I'll be taking most of the materials out of. And I think maybe the library, university library, or I think the HITLab also has a small bookshelf, so there will be a couple of copies of these books, so feel free to grab it and have a read. Sorry?
We've been buying it, or was there enough copies?
We had a couple of copies in the bookshelf. Let me first chase it inside the lab and see if we have enough copies. Otherwise, you can also borrow it from the university library since you are enrolled students. So,
Big into having your own copy. That's
yeah. So if you are really keen to have a copy of yourself, then that's fine. Again, it's not mandatory to have a copy of book because I'll be mostly giving my lectures based on my slides, so don't worry too much about that. But it's still worth to have a read of that book, which kind of gives you an overview of the whole research methods in HCI or human interface technology field. And the other books I'll be using time to time one is a book about statistics, which is kind of, if you haven't done statistics before, then this might be a good introductory book. But again, whatever material or books you have about statistics, that's fine. I'll be, again, showing you or introducing you to certain statistics methods that are frequently used for HCI researches. So that itself could be quite sufficient enough, I think. And some of the statistics methods not covered in this basic book, some of them will be taken from this book. But mostly the research methods we'll be talking the topics in this book. So it's there. So although it's not covered in either of those three books, I'll just briefly go over kind of brief history of HCI. So when was your first time you encountered with computers? Can you briefly remember around when was it?
I grew up when they arrived.
Yeah, you grew up and they arrived. Yeah.
8 maybe.
8?
With dad bought a computer for us to play with. We had to like play a game with that enter the code.
And do you know what kind of brand or what kind of operating system was working?
286.
286, yeah. 286. Yeah.
Yeah, they had a huge 20 megabyte hard disk.
20 megabyte was huge back then. Yeah, of course. Yeah. Yeah, I think 286 was usually 640K or sometimes even 1 meg. and has any of you have seen a little bit earlier version of 8-bit computers like Apple ones or
Old
Commodore? Wow, you've seen Commodore?
Yeah.
Wow, it's quite an old one.
No, it was when I was working on Person had one and he got it going again. Incredible.
Wow.
I don't think it had a hard disk.
Oh, so yeah, Commodore sounds quite old. So yeah, so I think mostly most of us started having a look at computer or used computer since they had some kind of screen and keyboards. But at the very early days, like in 1940s, when the first big digital computers were built, they didn't really have keyboards or screens that you can look at or type in something. But as you might already know, the world's first electronic numerical computer, which is ENIAC, built during the World War era, they were using connecting wires to give input to the computer. So it was not typing even or a button, but just connecting wire from here to there. And then also the output was just some light bulbs that has specific purposes. Like some of them shown the status, some of them shown the output data in bits and sort of things. And then later on, they introduced, to make it a little bit more easier than wiring them, they started to include a kind of tape reader, which was basically a long reel of tape, paper tape, and you had to have a hole to represent the bits, zeros and ones in each row, and then the computer read them through either a mechanical way to, or an optical way to read them. What are these written in this long reel of paper? And some of them also had a kind of card deck, so they had to have kind of hundreds of cards with punched or even marked in black with black ink to make it read into the computer and then get the results back, usually in a printed form or printed form in a paper. So at this stage, it was not really interactive, so to say. So it was more like you punch your paper or mark your paper and then you throw it to the computer. It runs it and gives you back some kind of results, like days after, hours after. But later on, they kind of evolved into a little bit more interactive way. So started with some buttons that you can press and then hit a special button that inserts that data into the computer memory, and then it will blink some LED lights to show you that it recognized your input and so forth. So this is one of the pictures of early IBM machines that had a large control panel there with like dozens of even hundreds of buttons that they can press or look at the LED lights. So later on, even becoming more interactive, at last they gained some keywords that you can type in alphabets and numerical numbers and see the results printed out on a paper. So it first started with teletype machines, which is basically a typewriter that is connected to a computer through a wire, so that the thing you type will be recognized by the computer. And once the computer has processed something, it will type back onto your typewriter. So it was basically a typewriter that has electronic connection to a computer. And then later on, it got evolved into a kind of more of a terminal or electronic terminal, which is quite similar to computers we look at these days. Again, until this stage, it was mostly character information that you typed in and you saw on the screen or on a paper printed out. But then there was also some researches going on from early 60s that people were interested in graphical input and output methods with computer. So, and Ivan Sutherland is called kind of father of computer graphics, and he has made a lot of he has contributed quite a lot at the very early stage of computer graphics research. And one of his main research output was called Sketchpad. And I think this was his part of doctoral thesis or something, I say. And here he kind of modified one of the computers. I think they say was TX2, although I haven't seen TX2 in my lifetime. So I cannot really tell, but just it looked like, it looked like this and had a lot of buttons. And it had a small screen. It was not originally designed to draw graphical stuff or get graphical inputs, but I can easily imagine it was mostly for rough text output or something. But Ivan Sutherland modified it to make it work with more graphical interactions with the computer. So this is one of his very early, one of the very, I mean,
Did they go to the moon?
yeah. So let me show you a short video clip of actually that working, and maybe that will give you kind of and.
Sketchpad. This was done in the summer of '62.
Yeah.
Now notice he did something that we all are familiar with, but now he's pointing to all these edges and he's telling Sketchpad to make them all mutually perpendicular. And Sketchpad figures out.
So as you can see here, it was quite amazing that he had this, although the drawing was very rough, it was just line drawing, but he had this light pen to interactively give input to draw lines, and he was able to even give constraints like make these lines parallel or make this line linear to each other and so forth. And it was quite, in this example, he was drawing some edges and draw some arc and gave some constraints. And he had some buttons on the left side to give some other inputs, such as making it perpendicular or to each other, or making it parallel to each other, and so forth. Yeah. So thinking it was like in 1960s, in 1960s, and I'm not sure if you have recognized it earlier, but he had like some concepts like zooming. So like here, he was able to zoom into that drawings and so forth. So it was quite already amazing what he had built with a kind of a computer that was not really built to draw graphics and interact with it, but he kind of modified it into a way that do graphics and stuff. Yeah. So Ivan Sutherland's work back in 60s kind of gave a lot of influence to later days in graphical user interface. And also another person who drived making GUI interface or graphical user interface to public was Douglas Engelbart, who invented the mouse itself. And he demoed this kind of mouse, which is made out of a wooden box with two rollers underneath. So one in x-axis and the other in y-axis, and I think it had one button on the side, so you can actually. It was pretty much working as the same how mouse these days are working. And he gave a demo of this system in a conference, one of the early computer conferences in San Francisco, and he actually gave a live demo, and that demo is actually called the mother of all demos, which is quite amazing and quite interesting to watch it. So I'll briefly skip through his demos. It's 1.5 hour clip, so I won't be showing everything, but if you're interested, you can just type mother of all demos in YouTube, then you'll be easily find this clip on the YouTube. So this is Doug Engelbart speaking. So he's trying to demo, and then I'll just skip through. So it was, although he was using mouse, it was not highly graphical user interface, but it was mostly text-based. But still, he was able to drag and drop something or copy something using a mouse and reorganize the data. And if you scroll later on, and you can see here, he has a pointer here pointing at certain items so that he can click on or choose from, or
say, I'll defer my access.
Or later on, he has some rough coding base. And if I scroll back a little bit, he even had a kind of online collaboration system with a remote person working together with a single document together. So it shows quite a lot of concepts there, showing how you could interact with the computer using a mouse and pointing at some information and selecting them, and even collaborating with a remote person. So again, this was back in 1960s. So it was quite amazing that at the very early stage of computer research, they have been looking into how people could interact with computer in a more easier way or in a more efficient way. So these inventions in 60s kind of fed into more modern day personal computers. So Xerox has been one of the leaders back then in 70s, kind of developing new type of computers for personal uses, and at the same kind of time frame, Apple also they started with a circuit board type of computer, which was for hobbyists, obviously back then. It was, yeah, and then later on they developed a more commercially packaged Apple II product in '77, which became one of the big hits for making computer as a personal device rather than something sitting in a big room and that you have to book for accessing it. And then IBM, who were mostly focusing on big mainframe computers back then, they got shocked with how people are thinking computers as a personal device they can own at home. So they were shocked, so they kind of started developing their own version of personal computer, which was called IBM PC. And their strategy was built that on an open standard architecture, which means the motherboard and peripheral boards are designed in a standard way to be integrated, so people can buy different parts from different manufacturers and then build their own PCs, which is what have been evolving until now. That nowadays you can easily build your own PC with standard parts. And so until this stage, still the PCs still had kind of character-based user interface, which was typing in some words in characters on keyboards, and then the screen will usually show you some characters as an output. And the operating system, it was again still a character-based or command line-based interface that you had to interact with. And then as some of the early researches that Ivan Sutherland and Doug Engelbart did on graphical user interfaces and mouse type of pointing interface, Xerox has been developing quite actively a personal computer that's based on graphical user interface. So if I show you this was the screen that they developed in early 70s. So it's quite amazing. Although even it's in black and white screen, it still has some concept of windows separated into windows, some icons there, and was developed back in early 80s. Although it was not that successful, the main reason was it was too expensive for people to buy for their own purpose. But still, it's quite amazing they put quite a lot of effort to build this system. And it's even known that they did some user testing back then to make the user interface more kindly to end users. And then based on these early efforts of Xerox Palo Alto Research Center, Apple kind of picked some of the ideas from them and built their own system. And obviously, they made a more commercially successful version of graphical user interface using PC.
When was the hard disk introduced?
Sorry?
At what time?
Hard disk. I think hard disks for mainframes were quite from early days that had like big, like couple of inches of hard disk. I think usually early PCs had like 5.2, 5.25 inch like floppy disk that was really floppy actually. Yeah. And then later on, I think when the first Macintosh was introduced, they started using a little bit more compact 3.5-inch discs, and then I think it was a little bit later the consumer version of hard disk was introduced later on. Yeah. So to kind of briefly wrap up what we've looked into, so in late 70s and 80s kind of shifted the computing devices, or computing is shifted from mainframes to personal computers. And as the type of devices were more focused on personal use of computers, so that made people more interested in making computers more easier to use by a normal or novice users rather than engineers or technical experts. So the human-computer interaction, as a research topic, also gained quite a lot of interest in these days, where the computers were becoming more a personal thing to use at homes or workplaces. And since it was for selling for personal uses, if it was too hard to use, then many people will not buy the product. So that was one of the reasons. So it was around early 80s and late 70s that they started having the first. So it's actually 1982 that they had first HCI, or human-computer interaction or interface-related conferences, academic conferences. And I think the conference itself is called CHI conference, which stands for Computer-Human Interface or Interaction. Back then, they were more focused on the computer side of the topic, but later on, these days, they use HCI more than CHI because of kind of the paradigm of the research shifted into focusing more the human side of technology rather than the computer side. Or it's actually the same word, but just kind of thoughts behind to make it more human-centered or human-oriented, I would say. And in early 80s, it was mostly focusing on how to make word processing more easier or database interfaces. And as web or internet became more popular, the interest became shifting to making the website looking or easier to use or easier to access information from the web and so forth. And also late 90s multimedia stuff like integrating movie clips and audio clips and making it into an interactive CD-ROM title was one of the topics interested in back then. And then in early 21st century, it gained more different or various types of interaction technologies, including some motion recognition using cameras to detect your motion and so forth. So to summarize all of those into one slide, you can easily think of human-computer interaction in two ways. One is how to provide input to the computer, so how you can provide input or message or give command to the computer. And the other way around is to how the computer will make an output, which will give a feedback to the user about what the computer has processed or what's the results of the processing. So early days, again, using connecting wires or tapes or punch cards and keyboards, and the output was some blinking lights or on the display, or eventually got into printing some characters or sentences on a paper. Then it's more of today's keyboards and screen with mouse cursor and GUI elements are pretty much well accepted in public and widely commercialized. And we are kind of on the edge of kind of soonish, or even it's happening now, that some of the wearable computing stuff like Google Glass or other type of wearable computing, or even smartphones that we carry, and touch interfaces and so forth are happening at the moment to be more natural, to provide a more natural way to interact with the computer. So, so that's kind of rough or brief overview of the how computer has evolved in terms of how you interact with the computer. And the research in human-computer interaction field involves quite a number of different disciplines, especially since it has two entities in this topic. One is human, and the other is computer. You can easily imagine there's already two kind of topics there, and there are quite a lot of different topics surrounding these two entities. On the human side, cognitive psychology or human factors, or such as physical factor, or such as the size of the keyboard that feels easy, or the positioning of the computer monitor to make it easy to use, and so forth. All those are also included in HCI research field. But at the other end, where computer scientists or computer engineers are more interested in are software components or software libraries that builds this kind of interactions much more easier. And even these days, management or communication also look into HCI field, where laying out the information in a way that people could recognize it easier, or the menu structure, how people access the information. Those could be quite interesting for those who have communication background. Also, arts and design also stepped into HCI recently as more multimedia interfaces are gaining popularity. So since there are quite a lot of different disciplines, academic disciplines or academic areas involved in this HCI research field, there will be always many different approaches or many different methods that you'll have to learn or use while you do research in HCI field. And as we can easily imagine, each discipline or each field of each academic field has kind of different traditions or different approaches they usually dealt before. So some of them might be more focusing on theoretical stuff, or some of them might be focusing on more practical stuff. So there has to be some kind of understanding that you might have to deal sometimes both. Sometimes you have to make sure different aspects of the same topic could be thought of. And since this is kind of a melting pot, it's not only that these methods that has been used in different disciplines are just brought in, but they are modified for the HCI research itself. So some even new methods are created in HCI itself. So you have to be aware of that. The things that you know might not be the whole thing that those who are working in HCI field are using or looking at. So so again, there could be quite a variety of methods or approaches, and also even from the evaluation side, different people from different academic background might look into different types of evaluations. So some people might look into test completion time, such as those who are very interested in how tasks will be efficiently done by certain interfaces. But some of the people, such as from art or design background, might look into more user experience as a whole thing, such as how users are satisfied using the user interface and so forth. And still, you'll have to think that all these varieties are all in one, under the name of one big HCI research. So, so please be minded of there might be some different point of views when you talk to someone who says I'm interested in HCI, but that might mean that he is an artist that designed some nice looking thing for human-computer interaction, or even it could mean that someone designs electrical circuit boards or for new sensors for HCI. So please be minded of those. And as there are quite a variety of people involved in this, of course, communicating your own thoughts with these other colleagues and researchers are that then you might have to be aware of that you might have to mind that they might be talking different from the different perspective, or might using different language even sometimes, that when you talk about the same topic. So so please be ready for that. So that's a kind of general overview about what HCI field is about. And then I'll maybe we'll have a short break now, maybe 5 minutes break, and talk about more details about what evaluation takes part in this large HCI research. Okay, so it's a little bit early, but I think it's better to keep the topic the same session. So maybe we'll start again at.
I don't know. I should stop it after the end of the lecture.
Mm-hmm.
Should I just leave it? That's a bunch. Consider from here. Just have.
So feel free to grab water or keep your nice hands. Okay. That's bright enough to not get into sleep, but dark enough to get the screen. Better. So, so coming back to our main topic today, which is evaluation. So let's see where does this evaluation fit into the whole HCI research topic. So this is kind of the things that you might do or go through a human-computer interaction research, or even you can think of your own thesis, or if you write a paper for a conference or a journal, it might include these kind of components inside there. So first, you might start looking into identifying problems or needs of the end user requirement. And so you might find maybe the current layout of keyboard has a certain inefficiency or has a certain problem, so that you want to invent a new type of keyboard or type of character input method. So, and when you're doing this, it's always compared to the state of the art. So it's the first thing you might encounter in a research paper in human-computer interaction. Of course, it will start with an introduction. What's the current state of the art, how they do this in using a computer, and what's the problem of that. And usually, comparing the state of the art comes in the second section called related work or previous work or whatever. And then once you've identified what is the problem you are interested in, what is the problem you want to solve compared to the current state of the art of technology, then you look into designing a solution for that problem. So you might design a new layout of keyboard, or you could come up with totally different type of user interface that does character recognition or handwriting recognition or whatever. So you start designing a solution. And then the next step will be implementing it to see if it actually works or not. So you can, if it was a new keyboard layout, then you might take out all of the keycaps, and then maybe you can rearrange them and write a software that does recognize a different layout, something. Or even you can even do soldering of a new circuit board, that if you were building a new specific type of hardware. And then what you end up with once you had that kind of prototype or implementation, then the final thing you'll have to do is actually evaluate or test it to see if it actually works or not. So when you are evaluating it or testing it, you're always testing it against the identified problems, the very first thing that you did from your start of the research, to see if it actually, your design or your solution or your prototype meets the needs or requirements that you identified at the very beginning of your research. So, so again, these components are the main things that you deal with HCI research. And as you can easily see here, these three topics are actually the three parts of the lecture. So design is done by Christoph. Prototyping implementation, Adrian and Mark will be covering that part, and I myself will be covering the evaluation part. And again, this structure or even the order is usually how you write a report in HCI research, either your thesis or conference paper or journal paper. So if you think of these components throughout your projects, yep.
Supervisor based on
I think the allocation will be done the week after. So next week. So this week is just the first week will be lectures, and then the next week I think is the week for you guys start thinking of your thesis topic, and then Yeah, next week, and that's why we have no regular lectures, but 2 guest lectures by Tom Bernice. So
What day were they on?
Monday 10,
Tuesday.
yeah, Monday and Tuesday 10 to roughly 10, 10:30, 11 or something. So anyway, next week you'll be start thinking of what kind of thesis topic you want to deal with, and then the week after, once Mark back, I think based on the thesis topic you've thought of, we'll assign the supervisors. So anyway, evaluation comes at the very end of the whole process, but the main thing is if you haven't got this step done, usually you'll end up with a question mark which asks if your solution was really working or not. And you cannot really tell if it was fixing the problem you identified, or you cannot really tell if that satisfied the user's needs or requirements. So it's kind of a critical step that you, as wrapping up all of your researches and making it as a whole, and being meaningful as a final output of your research. So looking more details into evaluation, what is evaluation? I'm not asking about dictionary definition in dictionary, but what do you think an evaluation is? What do you think? What do you think to do, or what kind of things do you think you'll have to do when you're evaluated?
Quality of the work needs to require standards.
Sorry?
Quality of the work needs to require standards.
Yeah, quality to make the work standards. So you have some standards that you have to compare against, and it's mostly about quality. How good is that solution, and so forth. So this statement kind of roughly shows you what we are concerned with when we are doing evaluation. So you'll be, to make it simpler, sound simpler, is mostly gathering data about the quality of a design product. So in terms of quality, especially in human-computer interaction or human interface technology field, the quality usually means usability or user experience, which means how useful it is, or how easy to use, or how easy it is to learn, and so forth, or even overall user satisfaction, such as these days it became a little bit more broader, such as was the user comfortable when it was using it, or was user felt satisfaction, or user felt even happiness, and so forth. So those are the qualities that we compare against with. And there are certain standards, of course, but these standards are usually yourself as a researcher set at the very first stage of your research. So you start at the beginning of your research, you have to state your goal or overall standard of what your solution or your new type of interaction will be have to meet with. So, and in the end, once you've gone through the evaluation, the outcome of the evaluation will be what worked and what didn't work, of course. So when you evaluate your design prototype, you'll end up with this worked as I've planned, or I've imagined it at the beginning when I set the goal. And you'll obviously also find out some of the things that failed to work, or wasn't easy to use, or was slow in the process, and so forth. But all of these ideas are actually not completing the whole research process as ending the whole process, but these are actually feeding back to the previous processes, such as designing the product. There might be something wrong with the design, or there might be something wrong with the implementation. So usually what the outcome of the evaluation is not thrown away or just stand as it is, but it's usually given as a feedback to going into another iteration of other processes. And you might also not, there might be also different types of outputs you get from evaluation, not only the known things that you had a checklist looking at which one worked and which one didn't, But you might also encounter some new things that you didn't thought of before when you were first formulating your research project. So usually evaluation involves users, although I'm going to talk a bit later. And users can do whatever crazy stuff they can with your prototype. So they can even use your prototype in a way that you didn't really meant to use it is. But sometimes it could be sparking your own ideas from there that although even though that was not a planned thing, it might be a better way to solve your problem, or it might be a kind of very novel way to work around the problems as well. So if we put that together into a diagram, you can think of at the very first stage of your HCI research, you identify the needs or problems as a requirements. And then based on this problem statement or requirement statement, you go into design stage where you design on a paper or on a graph editor or something that you design how to make your own human-computer interface. And then once you've designed those, you start to implement it either in a software-wise or build a small hardware prototype. Once you implemented it, you test it or evaluate it if that actually meets the needs and requirements that you first stated at the first stage. But again, this is, and if your product satisfied all of your initial goals of your research or design project, then it could be released as a version of solution. So it might not be the final solution that is perfect, but it could be one version of solution that you release. But if it fails to satisfy some of the needs or requirements that you've first set at the very first stage, you might want to go back into one of the stages you've done at the beginning. So it might be a very simple problem that it was just some of the chips on your circuit board was a little bit loose, so that you have to solder it out again. So that might be going back into implementation stage that will make the application more solid. Might also go into the design stage, where some of the design of your new user interaction might have some flaws that you didn't thought of before. So you might want to redesign some of the stuff, and even you might end up based on the evaluation or user test, you might end up revisiting your problem statement or requirements and see if that are really valid, or if you're and check if your problem statement or requirement was actually not the main problem, but it was touching the surface of the bigger problem underneath. So as I've mentioned through the graph in the previous slide, so the purpose of evaluation is first to validate our prototype or solution to see if it's good enough to be released as a final product or a version of product. And the second one is to refine your prototype or your own design. So the results of the evaluation will be giving or informing the previous stages. And some of the cases at the very early stage of design, you might have some questions about which you might have multiple design choices, and you might not be certain about which one is the better. Then evaluation might also be one way to decide which one is the way to go with. So, and then again, it could be go all up to the very first stage where you have defined your problem or the thought that you had about the user. So it might even let you go back to that very early stage and see if your own problem statement or the requirements that you thought of and view on the problem was valid or not. And in overall, that wraps up. That ends up that I would like to say the evaluation is not the final end of the whole process, but it's rather a stage where you might want to go back to some of the stages and do the iteration. So building on that idea, when is the good timing for doing the evaluation or testing of your product? So one typical way, and we end up in many times in this kind of schedule, that we design something, implement something, then evaluate it, and then and once we've went through quite a lot of designing and implementation, and we had quite a well-developed end product, then we try to evaluate it. And if you do in that way, usually the course might be a bit rapid, since we are not waiting for the evaluation of interim products, and since we are doing the evaluation at the very last stage, the cost might be less for evaluation. But the problem is, if you find a serious problem at the end, then you'll have to redo everything, and that will actually cause more problems, or even some cases it might end up with throwing out your whole design and working from scratch again. So on the other hand, you can think of testing or evaluating along as you develop your own design or develop your own prototype. So this might feel like it is a little cumbersome that you have to test it at every stage, but in the end it might end up with making your overall effort and cost and time, in terms of cost and time that you put into reaching a certain stage that is complete enough to deploy, might be less than what you had on the other hand. So there is a saying that we might have heard of, that you can fix it now on the drafting board when you're building a building with an eraser. So if you are still on the design phase, then you can easily erase it with the eraser. But if you already have been building it, then you might have to demolish some part, or it might take more cost of yours to fix it later on. So so evaluation or testing phase are please don't think that that's the very last thing you'll have to do with your project or with your thesis. So please think of the evaluation or testing at the very beginning of your project, and please remember that testing could be involved on every stage of your project. So usually they summarize into 3 types of testing, depending on which stage of your project is going on. Yeah, I think I forgot. It's no battery, so maybe I'll just continue on. So the first one is formative testing, and this one is at the very early stage of your design project or HCI project. And you might have some very low fidelity prototypes. You might even have some just rough drawing of your screen layout of your new interface, but you can still test with it, showing it to another person or someone, getting some feedback, and that itself is one of the type of evaluation. So it doesn't have to be kind of very restricted, controlled user experiment, but you can still do some of the evaluation at the very early stage. And in this stage, your evaluation process will be more focused on how user perceives your design. So either how user likes the layout of your buttons, or how user likes how you designed, or even if color is one of the components of your design, then you can test how people likes that color and so forth. But in this case, what you do not consider that much is how completely it works, or how easy it might be for a user to press something or so forth. But still, you can do certain types of testing based on low fidelity of prototypes. And in this stage, you could also do some testing comparing multiple options that you have as an idea. So you might have a couple of ideas that you want to choose from, and you might roughly, if you had 2 or 3 different alternatives of the screen layout, then you might draw it or sketch it quickly and then show it to some of the colleagues or users and get some feedback which might be better before you start. And then the second type of testing is in the middle of while you are actively developing and revising your prototype, and you might get some more formal prototype, half working or so forth. And the goal at this stage will be evaluating the effectiveness of specific design choices, such as if you had some screen layouts and you had a kind of rough working prototype of that website, the images might be just place-holding things, or some of the buttons might not might be just standard buttons and so forth. It doesn't have a nice image of a button, but still you can test with some certain design choices, especially in terms of effectiveness, how user quickly does switch from one screen to another, how effectively or efficiently navigates between the menus and so forth. You can still test with those and make design choices. And the last thing is called validation testing, where your product or prototype is almost ready for release, so that you want to make sure everything is working and your solution actually makes the point that you first set with the goal and with the requirements. So, and the people involved in your user evaluation could be varying in terms of the phase of your whole project. So at the very early stage, you yourself might be the one who's testing your prototype, of course. So you might be testing and using it yourself. So and then you might also show it to your colleagues or some experts, such as your supervisors or so forth. And this might happen in the very early stage. But as you go along your along with the process of your research or your project, then you'll start getting involved with the end users and the stakeholders that you might want to test again. And this might be more in a formal way, such as a user experiment that you define a specific task and ask the user to do that task and measure some timing or error rate and so forth. And this might happen more frequent as you have a more mature type of and also you can think of different places you can actually test your prototypes. So there are certain approaches that some of the testings are done in the field at a place where the users actually use them. So if you have designed say an AR browser that runs on a smartphone and it's meant to be used outside somewhere in place, then you can easily think that testing it should be done at the place where it has to be used. And in this case, most of the case, you might be mostly observing how they use it, or you might also can ask them how it went well and so forth. But it might be a little bit tricky to measure accurate measurements, such as accurate timing or measuring accuracy and so forth might be a little bit tricky compared to the controlled user experience that you can do in the laboratory setting, where you can have different equipments to measure timing or accuracy of pointing and so forth. So it has cons and pros, but in the laboratory settings, it's more controlled environment, so might be different from the environment where the end users might be using your end product. So you might not discover some of the problems that actually happens in the real world, but not in the laboratory. But and also another option is you can actually do your evaluations remotely. So such as if you can actually, if you are testing your website, you can actually mail out some surveys to the end users or have a survey site that the end users tries your website and uses your questionnaires and so forth. So you can think of a remote, having an evaluation done in remote. Sorry?
A couple of the programs out there, SurveyMonkey and
Yeah, SurveyMonkey is also one of the good programs. And I think university also provides some tool, I think it was called Qualtrics. They have their own account on Qualtrics, so you can run your own surveys. So, but again, this might be less controlled, so people might throw in some garbage information to your survey and so forth. So each places has concepts, pros, and there is no ultimate answer. It depends on what kind of research question or what kind of end goal or requirement you have. So, and saying all that, how to do the evaluation depends all on quite a lot of things. It depends on, and since many of these things are tied with resource available, the time that you have to deliver your report or some financial stuff that even if you want to test it on site, if you have designed something to run in Australia, Sydney, then might be a financial problem that you cannot really travel often or so. Then you might have to fall back into remote testing. So there are quite a lot of different things that you might have to think of when you plan for your evaluation. And there are also quite a lot of a range of different methods and techniques that we can use for evaluation. Those are what we are looking through for the rest of this session of the lecture. So just to give you a quick overview, we can think of 4 different approaches for evaluation. The first is quick and dirty, which we usually do quite a lot of times by ourselves when we are developing quite actively in the development phase, and especially in the formative phase of your project when you're trying different stuff, then might not have formal evaluation, but you might do it just strictly with whatever person you have. Field studies is mostly about when you're focused on the use of your product or prototype at the place where it's meant to be using. So you usually visit or go together with your end user and see how he or she uses that product. That's a type of field study. Laboratory-based studies are more formal, controlled user experiments. So you can have different types of user interfaces and let them use to do certain tasks and measure some time, how long it took to complete the task, or how much error they made, and so forth. And then there's also another type of evaluation called predictive evaluation, which is based on experts or guidelines. So there are some heuristic guidelines in HCI field, such as saying that, for instance, can easily think of something that an error message should be appearing at the center of the screen to make it more visible and so forth. So there are certain guidelines depending on the topic, such as there are certain guidelines for web pages, there are certain guidelines for graphical user interfaces on certain operating system and so forth. So you can check against those guidelines, but not as the end user, but just check with those guidelines and predict how good. So a little bit more details about each. Quick and dirty, you usually end up with informal feedbacks, usually in saying or in conversation. So and might be very rough early feedback that just gives you a rough idea of how they liked it or how did they like it. If they didn't like it and which part they have concerns, and that might give you some feedback how to revise your early prototype in the next step. And the good, and although it's an informal feedback that you might not end up writing them in your final thesis or report, usually they don't refer to this kind of evaluation, still helps you to refine your product and make it better. And the good thing is you can do it anytime, anywhere. So you can ask the person sitting right next to you or whoever, or you can just ask them quickly. So it's a good thing that you can do it at your convenience time. And the main point is to get a fast or quick input to your current product so that you can identify the problems, certain problems at the early stage of your development, so that you can fix it. And field studies usually done in natural settings, and where the end user actually uses the environment. Again, if it was a mobile device, then you can think of actually going with your end users. If it was a GPS navigation device, then maybe you can ride on a car together with your end user and see how he uses, and so forth. And in this type of studies, it's not only your design solution that you're interested in, but many times you're also interested in how user actually does certain tests, so that you can get some ideas or new insights of understanding how to design or change your design of your product in the later stages. And these type of studies are useful for identifying new opportunities in terms of how the user actually did the task that you were interested in, or deciding which kind of requirements that are actually needed that you haven't identified by yourself. For instance, if there was some serious noise happening when you were riding on a car testing the GPS thing, then you might have not you might have missed that there might be quite a noise going on inside the car when you were first designing it, but later on in the field study, maybe you might find out those requirements that are needed. And of course, you can also evaluate your own product. Laboratory-based studies are done in controlled lab environments, and usually happens at later stage of the whole project, and when you have more solid or more reliable prototype. And in this case, it's quite easy to record what happened, and some of the measurements, such as time the participant took to complete certain task, or error that they made when if it was a pointing device, then we can easily record how much error they made with pointing at certain targets and so forth. So those are the merits of using lab-based studies. Predictive evaluations, again, experts who has knowledge of certain guidelines, heuristic guidelines, can easily look at your product and pick out some of the problems that that users might easily encounter based on the guidelines. So could be relatively quickly done, since you have a fixed set of guidelines you have to check with, and you are not scheduling for like 10, 20 people to come to the lab and try it. Just one expert could just go through the guidelines, could take less time, but depending on issue. So, but still, since it's based on heuristic guidelines, it's already set up. It might end up, you might miss some of the actual problems that might happen in the real world. So, summarizing the table, quick and dirty, in field studies, web studies, and predictive methods. These three involves users in certain ways, but the last one doesn't involve the end user, so it's just yourself or an expert that checks the your product based on the guideline. In the quick and dirty stage, maybe you might ask them to just freely try to use it, but with more formal lab studies, you might ask them to do certain tests so that you can compare certain errors or test completion time and so forth. And location-wise, quick and dirty doesn't really matter. Predictive method also doesn't really matter since you're just checking against guidelines. Field studies and lab studies differs in terms of field studies are more focusing on natural settings of using the product, while controlled environments are preferred for lab studies. And the stage of your project, quick and dirty or field studies are more at the early stage of your project, so that you can identify early problems and choose from different design alternatives. But the lab studies or predictive studies could be more used at the later phase of your project to validate your end project. And at the early stage of your project, you'll be mostly getting qualitative descriptions and in verbal communication or in a written description that this part it was hard for me, it was slow to do, so forth. But later approaches, especially the lab studies, will give you more quantitative results, such as numbers, such as how long they took to do certain tasks, or how much of error they made, millimeters or pixels or whatever. So it will give you more quantitative measures so that you can test them against statistics and show how meaningful is the results based on the statistics. So, and for these type of approaches, there are certain methods that you can use with. So these are the main methods that we might look into more details in the later lectures sessions. And so the first one is, the simplest one is to observe how user uses it and see if they have any problems and so forth. And ethnography or case study is more of like a case of field study type of study where you visit them while they're using it in the real world and see how they use it, or even be part of their team and do the test with them and observe or record how they did the task with the given user interface, so forth. And another way to do is actually ask them certain questions about the product, how did they like it, dislike it, which worked and not, and so forth. And focus group is a kind of interview, but doing it in a group so that you ask multiple people to come together and discuss about your product, and evaluate it as a group. And surveys and questionnaires. Surveys are basically asking a multitude of people to fill out the questionnaire. And the questionnaire is basically written questions that you might want to ask the question, such as asking which, if you were testing multiple options, then which one did you like most, or which one do you think is the most efficient, and so forth. And then there are more formal studies such as usability testing that test usually against the requirements and see if there's any problem or the final product. And also more from a research perspective, a formal user experiment which compares different technologies and sees which solution is better than the other. And again, these variety of methods could be used in different phases of your project. So at your early stage of your project, you might use some informal methods such as observing the user and asking some questions and such way. Of course, interviews can be also very formally structured, but at the early stage, or at the later stage of your project, you might do more formal user experiments. So, and again, there is no one solution or one answer that you have to use. So you always have to choose the right method that fits to your goal of your project and your requirements of your design and so forth. And it's also good that you also pick some of them and mix and match together so that you can have different answers from using different methods and from different perspectives so that you can actually they use a term triangulation so that you can pinpoint or point out, make more certain that your results or conclusions you've drawn for the evaluation to be more complete. So once you've done your evaluation, what you collect through the evaluation is, again, you collect some data such as what worked and what didn't, and if you encounter some new ideas to do the same thing in a different way, so that you can improve in another iteration of the design process, that those are feedback you might want to collect and cluster them into feedbacks. And then in triangulation, if you use multiple methods, then try to see the results and see if they match together. So if you design a pointing device, and when you asked the user, he said he felt it was not easy to use, but when you measure it, maybe it came up with it was the accurate way to do that kind of test. So you have to compare different methods and results and see if they go together or coincide with the findings, so that you can confirm that one finding is correct. Or even if you find some conflictions, then you can also think of what is actually making this kind of conflicting results, and come up with identify what is really causing the problem and try to fix it as well. And of course, when you're testing, you end up with checking if the results are relevant to the initial goals and requirements you've set at the beginning of the stage. And then once you've got your results written up, then the next thing will be iterate to either fix some designs or fix some part of your implementation, or even revisit your problem statement and requirements. So talk through quite a lot of things, overviewing the whole evaluation topic. This kind of sums up what you will be doing when you're going through evaluation, and this is based on these guys' paper, and it's called the decide framework, and it's kind of represents each step of it kind of shows you what kind of steps you will be going on when you're planning for your evaluation or even the whole research project. So first, you'll have to determine the goals that you want to deal with your research project, and you might want to break down into more specific questions, such as if you're designing, again, a new type of text input device, then you might break into how one question might be how fast user can type once they are used to it. Another question might be how easy is it to learn. So there's a new type of technology. How easy to learn might be another question you might want to ask about, and or even how easy is it to maintain it if your end user is a person who has to maintain the device and so forth. And so usually what you do is once you have the big overall goal, then you might break into certain research questions that you want to set into your research project. Then once you have those questions, then you will start planning what kind of evaluation methods you might want to use. So if it's as a simple question as if you have a rough layout of your website and you want to see which one is more preferred by the people, then you might easily use quick and dirty approach to just show it to your couple of person and see which one is better. If it's more serious questions such as that you are not certain with, then you might end up with scheduling a formal user study so that you can compare test performance or value. And once you've chosen your methods and techniques, then you might want to identify some practical issues such as how to recruit the users, participants of your study if you are going to find users. And you might also think of age group or what kind of background they might want to, depending on what is your end user, target end user is. And you might also think of other practical issues such as the space for the experiment. And then once you've done those, another important aspect is, since we are, in many cases, evaluation is done involving end user, it's quite an important topic that you think of ethical issues and privacy, especially privacy issues when you are doing user study. So that's also one thing you have to think of. And if your research question involves quite a serious, quite seriously related with privacy issues and so forth, could happen. Such as if you're designing certain products, such as related to security, or for instance, if you're designing a social networking application, that might include some of the privacy issues. So these be reminded that these type of problems are also one thing and we'll go into details. Then finally, once you've planned out everything, you do the experiment or the user study or interview or whatever you plan. Then you collect the data, interpret it, and if there are some numbers, then you can crunch it with study tools, and then finally write it out into a report or present it. And as a first step, again, as you've seen from the previous decide model, the very first step is to define your goals and your research questions. So that's the beginning of your planning your evaluation and even the first step of your research project. And if, as you can see here, and the user study is just a tool to help to answer those research questions you formulated. So if you just roughly think of the user study and just start to plan your user study without goals or research questions, then you end up with just like throwing arrows without aiming at the goal. But the important thing of using a certain tool is to have a certain goal that you want to meet, so that you use that tool. And evaluation or user study itself is a tool to validate your own solution. That goals and research questions are important. So this is one of the examples. So if, say, you invented Kinect at Microsoft and you want to see if that's a really compelling interface for gaming, then what you might want to do is stick for state-of-the-art technology, such as Wii or Sony might have had another competing platform technology, so that you want to see if your own solution is better than theirs, and that kind of and the goal might be releasing a compelling product that compete with existing technologies. Or if you are more oriented in academic way, then you might think of the goal as using natural gestures without holding anything. Is that better than holding something? More abstract kind of research goal you have. And then more detailed research question, you can go with how easy is it to use, or how intuitive is it to learn or to start gaming. Since it's a game, you can ask some certain questions such as how enjoyable it is, or how much stress you feel with. Is it more stressful to hold something, or is it more stressful to do some gestures in the air, and so forth. And so you can break down into more detailed research questions. And the research question you can define in different levels, but the better is to be more specific. So you can start with a question that if the new iteration technique any good, but you can replace this good with usable, which could be divided into different components, such as how it easy to learn or easy to use, or how fast you can use it, and so forth. And again, comparing, I mean, evaluating by itself is also good for making your product more complete, but it's always better to compare it with another existing state-of-the-art technology so that you can see where your product is in terms of quality and competence. And again, when you're comparing two products, then you might want to be more specific about is it about how fast you can do certain tasks, or is it about making less errors when you do some tasks and so forth. So it's more better to have more specific goals. It's because that when you have more specific research questions, then it's easier to formulate how you're going to evaluate your product and answer that question. So, and again, of course, since it will end up with doing the evaluation process, either user study or interview and so forth, while you are formulating your question, you might also need to consider those kind of factors, such as, is your questions really testable? If you formulated a nice question, but if there's no way to actually test it, then that's the dead end. So it's while you're formulating your user question, so it's better to think of how you will actually evaluate or test it against your own product. And you could also think of different types of approaches, such as exploratory or experimental research. Exploratory research is more about, think of the field research that I mentioned earlier. It's more about understanding how the user interacts with your product and how things work in the real world. So you might not have certain fixed answers that you have to check the boxes, but you might want to be more explorative, investigating the product as a whole. Experimental research might be more having certain levels of goals or questions, such as in terms of performance, or in terms of user satisfaction level, or so forth. And then you do a controlled experiment and then tick the boxes that and again, it depends on many different things, such as what kind of topic you have, or what kind of resource you have in terms of time or financial resources, and so forth. It's better to consider those stuff at the early stage while you are planning your topic of the research and the questions. So, which might be like, if there was no Google Glass at the lab, then maybe we might have had to think of another topic that doesn't use the Google Glass. Or if we didn't have a Kinect at the lab, then maybe if you're interested in gesture interaction, then you might have to think of another. So that's all for today. I have one assignment for this week. So
I guess this is online, is it?
Yeah, it should be online. I haven't still put on Learn, but I'll put it on Learn right away. And by the way, this slide is on Learn website. So if you go to HITD602 Learn, then there will be some stuff Christoph put with his slide, and I think he has to do. This part, beneath it, there will be the slides I've just presented now. And of course, at the end, the last slide is talking about the assignment itself, but I'll put another link here where you can submit your assignments after this. So 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 it's about writing a one-page statement of your interest in HCI topic. So could be if you're really certain about your own research project you want to do throughout your ambient thesis, could be that topic. Or if you have another topic that you have just had interest in before, as a side topic, then that could be also one thing. It's just to practice how to first formulate your research topic and question. So there's not a huge things that you have to do or don't do, but it's to just think of certain things, such as state of the art. If you had interested in like Google Glass, then you can quickly Google, look out on the website and see what kind of technologies are out there, and see what kind of problems they're having, what might be the problem, so you can identify your own problem. You can set some goals, such as you might want to invent new input method for Google Glass, maybe. And then you can divide it into research questions, such as if you are thinking of novel way of using just speech recognition, then you might come up with how efficient speech recognition will be, or how would speech recognition be more intuitive or more personal, or would it be useful in noisy environments or whatever. So you can break down into more detailed research questions. And since it's multiple, please make it at least 2. But there's no limit. But please keep it in one page. I don't want you to write 10 pages of things with this. So, and then if you can think roughly about a rough idea of how you would evaluate your product in terms of based on your research questions, then that might be it. So again, there is no strict guidelines of you should include these things, you should not do these things, but just to think of these kind of topics when you are formulating, just to practice think of these kind of topics when you're formulating.
This is due next week.
This is due next week, Tuesday, 1 week. And actually we don't have lecture next week, so maybe until next week.
The week after, okay.
The week after.
Friday week.
Maybe the week after. Yeah, we'll just. So yeah, so learn, those who haven't tried it yet, is learn.canterbury.ac.nz, and if you have registered, and if you don't see your subject on the lower left side on my course, please ask myself or Christoph to add your university account, and we have to know your university IK account to add you to the website. So yeah, so that's it. It's a bit over the half hour, but great. So thank you. And yesterday Mo asked me about what will be the assessment of this course. Yeah, you can.